Hello everyone, welcome to my channel One Concept W. This is one of the question on DC shunt motor. In this question, they are mainly including the concepts of armature reaction. They are mainly including the concept of armature reaction, and they are asking to find speed as well as torque. Let's get into the question. Here it is given. It is DC shunt motor and drawing an power of 5 kilowatt and terminal voltage of 250 volts, and it takes a no load armature current of 4 amps. Means under no load condition, it is taking an armature current of 4 amps and runs at 1200 rpm. An armature circuit resistance of 0.4 ohm and shunt field resistance of 250 ohm. At rated load and rated voltage, motor draws 26 amps full load current. Armature reaction weakens the main field flux by 3%. In this condition, they are asking to find full load speed and respect to electromagnetic torque of the motor. Let's write down what are the data they given. In the case 1, means under no load condition, it is drawing an armature current of 4 amps and terminal voltage of 250 volts and its speed of 1200 rpm and armature resistance of 0.4 ohm, field resistance of 250. Here we already know shunt field current is Vt by Rf. It will be 250 by 250, it will be 1 amp. That I shown here in the circuit. They are already given armature current of 4 amps. It is given they are drawing an armature current of 4 amps. By this I can able to find back EMF. Back EMF Eb equal to Vt minus IRE. Therefore back EMF is 284.6 volts. Now you see machine is acting under load condition. Under loaded condition, they given the motor is drawing a current of 26 amps. Here, we should be more cautious. This 26 amp is load current, not an armature current. Means it is taking a load current of 26 amps. Then field current is Vt by RSH. It will be 250 by 250. It will be 1 amp. Ia equal to IL minus IF by simple KCL rule. I found armature current of 25 amps. By this, under load condition, the back EMF Eb equal to Vt minus IRA. Under load condition, the back EMF is 240 volts. Here we already know when load current means armature current increases, it will produce an armature flux. This armature flux will demagnetize the main field flux. Means it will reduce the main field flux. It is already given in the question. They are giving the armature reaction weakens the main field flux by 3%. Means it will reduce by a factor of 3%. Means from no load case, this is from no load main field flux. This is full load flux. It is reduced by a factor of 3%. Even this is an EMF under loaded condition, no load condition, E2 EMF under loaded condition, phi 1 main field flux per pole under no load condition, phi 2 main field flux per pole under full load condition, and speed of motor under no load, N2 speed of motor under load condition. By substituting above values, we can able to find the speed of motor under full load condition is 1194.3 rpm. Along with, they are asking to find electromagnetic torque. Here, electromagnetic torque means the torque developed. Torque developed is Eb into Ia by omega. Omega is this speed, means under full load condition. Omega is speed under full load condition. Omega is in radian per second. Is 2 pi ns by 60. Eb is 240 volts. Ia is 25 amps. Omega is 2 pi into n 1194.3 divided by 60. Means electromagnetic torque developed is 47.97 Newton meter. Here, this is a very good question. In order to solve this sort of question, please subscribe to my channel.